In our example here, we have the function fx. Fx is equal to sec x, and the area between this function and the x-axis, between x equal to 0 and up until x equal to pi over 4, is rotated around the x-axis, creating a volume, and we need to calculate that volume. And we know that this is the volume formula. It's in the integration of integration from a to b, and the limits, or the limits are a to b, or the restrictions or the boundaries are a to b, and then pi, and it's fx, and you square this dx. Now obviously you can put this pi at the front of the integral, it doesn't matter. Okay, so now we can just substitute what we have. Well, we know it's going to rotate from 0 to pi over 4. That's the area underneath the graph, from 0 to pi over 4, and the fx is just sec x squared. So you've substituted all the numbers, all the things that are necessary, and then we just need to integrate and substitute all these limits. So if you integrate pi, it just stays pi, so these constants you can just keep like that. But if you integrate sec squared x, because this sec x squared is the same as sec squared x, and if you integrate that, you just get tan x, and now you must substitute 0 over 4, 0 to pi over 4, and to do that you just say pi, and then the one time you substitute pi over 4, and then you subtract tan if you substitute 0 in. So then you have you're left with pi, because tan pi over 4, this is just 1, and tan 0 is just 0. So it's just pi you are left with, and this is your volume.